In the world of medicine, there's this one number that can tell you almost everything you need to know about a viral infection. We're talking how aggressive it is, whether a treatment is actually working, and even how contagious someone might be. And that number, it's called the viral load. So in this explainer, we're going to break down exactly what that number means and why it's become such a critical, game-changing tool in the fight against disease.
So how do you even measure a virus? I mean, it seems like a simple question, right? For the longest time, our medical tests could only really give a simple yes or no answer. Is the virus there or isn't it? But as you can probably guess, that's only half the story. To really, truly fight an infection, doctors need to know more than just if a virus is in your body. They need to know how much of it is in there.
All right, so here's what we're going to cover. First up, what exactly is a viral load? Then, we'll get into the slightly nerdy but cool way we count it using logs. After that, we'll dive into the undetectable paradigm, which is a huge deal. We'll also look at a virus's life cycle, and then wrap it all up with why this number matters so much.
Okay, let's dive right in. What is a viral load? This is where we move beyond that simple yes or no test and get into the real numbers. It's a shift that has, and this is not an exaggeration, completely changed how we fight infectious diseases.
So a viral load is pretty much exactly what it sounds like. It's a count, a literal head count of how many copies of a virus are floating around in a specific amount of fluid, usually a tiny little milliliter of your blood. The best way to think about it is like a live snapshot, a real-time window into the war happening inside your body between the virus and your immune system.
Yeah, at its core, it's really just an exercise in molecular counting. It's an incredibly sophisticated way to count tiny individual virus particles. But here's the thing, when a virus starts replicating and goes out of control, those numbers, well, they can get really, really big.
And that brings us to the next big challenge, right? How on earth do you track a number that can swing from, say, 50 all the way up to 5 million? Just writing down the raw numbers gets super impractical, so doctors and scientists needed a much, much better system. I mean, look at a number like 100,000 copies per milliliter. That's actually a pretty typical high viral load for something like an untreated HIV infection. Now, just imagine that number climbing into the millions. It just becomes a total pain to write, to say, and especially to track over time. So to solve this, the medical community adopted something called the logarithmic scale, or, as everyone just calls it, logs. It's basically a genius shorthand for dealing with these massive numbers. Instead of writing out all those zeros, you're pretty much just counting them. So 100 has 2 zeros, that's 2 logs. 1,000 has 3 zeros, that's 3 logs. It's just a way cleaner way to handle these huge figures.
And you can see right here just how much cleaner this system is. 1,000 copies, that's just 3 logs. 100,000 becomes 5 logs. 1,000,000 is 6 logs. See? You're tracking the exact same massive changes, but with these tiny, much more manageable numbers.
Now, this is the really crucial part. Pay attention here. What actually matters in the clinic isn't the raw number. It's the change in logs. A 1 log drop always, and I mean always, means a 90% reduction in the virus. It literally doesn't matter if you go from 40,000 down to 4,000 or from 400 down to 40. From a treatment perspective, that is the exact same scale of victory. It's the percentage drop that counts.
And if you want to see the real-world power of tracking viral load, there's no better example than the story of HIV. Seriously, the development of this one test fundamentally transformed HIV from what used to be a death sentence into a manageable chronic condition. Let's look at how that happened.
So the entire strategy of modern HIV treatment, it's called antiretroviral therapy, or ART, it all boils down to one single primary goal. Get the viral load so incredibly low that our most sensitive tests can't even find it anymore.
And this is what those numbers actually mean in the clinic. Okay, so a high viral load, that's bad. It means the virus is just replicating like crazy. The first target for doctors is to get to viral suppression, which means getting under 200 copies. But the real, ultimate goal is undetectable. That's typically fewer than 50 or even 20 copies. And it's also pretty normal to see something called a viral blip, a little temporary jump that, importantly, does not mean the treatment is failing. And all of this leads to one of the most powerful and profound public health messages of our time. Decades of research have proven, without a doubt, that a person with HIV who maintains an undetectable viral load simply cannot sexually transmit the virus to a partner. This is the undetectable equals untransmittable message. You equals you, and it has absolutely changed millions of lives.
Okay, but viral load isn't just for chronic infections like HIV. It's also absolutely crucial for understanding acute infections, the ones that hit you fast and hard like the flu or, of course, coronaviruses. And for these viruses, the timing of the viral load is everything.
Now, check out this comparison, because it is fascinating and explains so much. With the original SARS virus, way back in 2003, a person's viral load didn't peak until well after they started feeling sick. That made it way easier to control, right? You just had to find the sick people and isolate them. But with SARS-CoV-2, the virus that causes COVID-19, the viral load peaks before or right at the moment symptoms start, and that changes everything. It means people are at their most infectious before they even know they're sick, which is a huge reason it spreads so explosively around the entire world.
All right, so let's pull all these threads together. We've seen how viral load works for long-term chronic infections and for those quick acute ones. So why does this one number carry so much weight across pretty much all of medicine?
I mean, just think about it from every angle. For a patient, it's basically a report card on how their treatment is going. For a doctor, it's the compass that guides all their big decisions. For public health folks, it's the critical data that shapes quarantine policies. And for researchers in the lab, it's the key metric for developing brand new therapies and vaccines. It's one single number that has a massive impact on every single level.
And that's really the magic of it, isn't it? The viral load is the bridge. It takes the invisible, microscopic world of a virus and it translates it into a single, concrete, actionable number. A number that has very real-world consequences for our health, for our treatments, and, as we've seen, for our entire society.
And our tests are just getting better and better, more and more sensitive. We're getting to the point where we can count just a handful of virus particles in a single sample, which leads to a final, pretty fascinating question, right? As this molecular accounting gets even more precise, what new doors is that going to open up for us? I mean, could we predict how severe an illness will be from day one? Or maybe even stop the next pandemic before it ever really gets started? The possibilities are really just beginning to unfold.